if you haven't heard the other episodes yet, I trying to get to know you a bit better. So going back to how you came into contact with robotics. So what is your background? Some people have mechanical engineering, some people have computer science, and yeah. So how do you actually came in contact with robotics? Maybe a bit of about studying. So how was your path, and then how you got into the because you're working already, right? So how you got into the job. I went through your CV and saw you have a few big names in it. And just yesterday you mentioned about your NVIDIA hoodie, or yesterday or today. So whatever you feel comfortable with sharing, share. And I'm not digging too deep, so it's not getting too technical and it's not getting too personal. I would like to just because my CV is a little bit different, and I like to find out what brought people into robotics, and maybe this can be an inspiration for other people that are just joining their career, or just joining the path, or they would like to switch their path. So I think it's always interesting to find out, yeah, how things came together and how broad is the field and how narrow can the field be if you want to. And yeah, this just like getting to know Chris, right? So if you would like to share a bit about this is my goal.
Yeah, sure. So I mean, I've actually been doing robotics stuff for a very long time. So when I was in college, I guess I started out with like an internship at the Applied Physics Lab, which is a government contractor near where I grew up, near where I went to college as well, and I worked at the U.S. Army Research doing robotics stuff in through college. So the guy that started so this is a very long time ago now. This is like early 2010s maybe, right? So then yeah, I mean, I feel like I've always been excited about robotics and technology in general because I feel like first of all, I think it's exciting. I mean, I've always been a big science fiction fan, and I think that it's great I think that what seems exciting about robotics in particular is that I feel like it has just so much potential to kind of help people make the world a better place, all that kind of stuff that I feel like we don't really talk as much about in technology anymore. I feel like that's maybe something that we're missing these days. So this is being inspiring about how we can make the world a little bit better. But uh, but yeah, so that's the original interest for me. I think I feel like in particular I am very interested in AI and planning. So basically, how things can reason, how we reason, how we make systems that can be intelligent and make good decisions about the world, and in particular how can we get systems that are able to come out into the real world and make that kind of difference or impact. And so that's why a lot of the research that I've been doing lately has been focused on like home robotics, particularly because I think that as we get like better AI technology, things like vision language models, understand it, we can pull in the kind of semantic understanding that lets robots act in the real world in an
Mm.
intelligent way. And that is kind of a first, like it doesn't need to be human level or anything, but but it's enough that it's got common sense and that you can start building useful systems and things that can really help people and make the world better and all that kind of cheesy stuff. So that's where I don't know what you really want to say. I don't know.
No, I mean it's interesting because you're so this is the it's so this for me sounds at least very academia driven, right? So
Yeah.
as I'm in manufacturing and our company is as a software robotic company, so we are mainly customer focused, use case focused, and so this is so everything you do and all the things that you are working on are the things um, that are mainly there to solve a problem, right? But problem solving can be very different. And we just internally in our company had a discussion about so what is actually driving the people that are working, for example, the machine learning engineers or the people working with the robots versus the people that are trying to sell them, right? Or sell the products. And yeah, so what is your take here?
Like what the differences between so I feel like first my background is fairly research focused. Like so I was at so I listed off what I did back in college, which is a very like those are research labs. I went to grad school in at Johns Hopkins University. Obviously very research focused. I did do some manufacturing robotics there, but I
Hmm.
think that which I think I mean I think that to a real extent like there are a lot of challenges in things like manufacturing robotics that are very interesting from this kind of like the exact same lens that I was just talking about, like making robots more useful, usable, reliable, making them more, but in particular, making things more general. I think that applies to all of these things. I think that then, yeah, and I worked at Zoox, NVIDIA, and Meta, which are all, Zoox was R&D, Meta and NVIDIA, both research with a less development. So, um, but what are the big differences between like those kinds of backgrounds and like directly trying to sell robots? I feel like it's just time horizon. My opinion is that like a lot of this stuff, when it comes down to it, until very recently, I have not felt like the kind of generalizable robotics that I've been talking about, like making a robot that can handle a situation that the programmer didn't necessarily see, is that did not really work until very, very recently, I would say. So that means that we were looking at to be able to make robots able to handle like particularly what you want, whether it's a self-driving car or a home robot or like a next generation industrial robot, I would imagine, is that you want a robot that can handle a situation that is like in the long tail of very rare cases, right? This is one of the things that these like there are a million of these, as I'm sure you know, that come up. Like if you've got a robot in the logistics center, like picking up some new object that it's never seen before, or that like catches in the gripper weirdly or something like this, right? So how do you make robots that can handle those kinds of situations? People can do this very, very well, right? We're very good at adapting to these things and handling like these out of distribution cases. But until you can do this to a certain degree of reliability, you cannot trust robots with anything important. And that means self-driving, whether it's self-driving cars or even Amazon picking, right? Like there's a lot of things that you can't trust, like in a warehouse. I'm not saying I don't have no information on what Amazon's actually going on, right? But like the point is, if you're trying to do, no matter what your case is, you have to be able to handle these kind of the long tail. So that means that if you're interested in that, like looking forward into the future, that is something that you need to target at some point. Right?
So you mentioned a few of the points or stations that you worked on. I mean, a lot
Yeah.
of people that are starting their journey. So this is like these are the places that people would like to work when they're coming to this. Not necessarily, but I mean these are big names, and especially NVIDIA. I think last year was. So it came to everyone's attention, and so do you would like to maybe, or if you can share a little bit of how is it working for these kind of companies, right? So how is it of you said that you're working for Meta at the moment, so this is very, very big into research, the departments that you're working on. How is it working in this kind of companies, this kind of size or importance in the industry? How is it for you, and especially if you're being on a conference or if you're speaking to other people on yeah, let's say on not only on social media but in general. So people are always very curious, how is it within those companies?
I mean, honestly, I think that's a good question. Because one thing is that as I've the couple of years that I've spent now after grad school at these different companies, I do feel like everything changes quite a bit. So
Hmm.
like I gotta say, my personal opinion, I think that everyone in my position or your position who has already kind of got broken in, I have to say I don't think any of our advice is going to be all that good in a couple of years. Like I think that that's a so I would caveat anything that I have to say about this pretty heavily, right? But my opinion, so one thing is that at these big companies, you have a lot of the resources, a lot more resources than you do in like say academic research. You have a lot of that means that you generally get like the best interns and the best students and the best resources. You also get the best press and PR teams, right? Like that's another thing that I think a lot of people get, especially more recently. So that means that like there's a big difference in the visibility of work that people do at these
Mm.
companies. I would say and that also means like the core like there's a flip side to that, of course. Like you have more if you have more eyes on you, that means certain things about what you work on, right? Like I think that, for example, I feel like that there was a nice video going around of like a cool dancing humanoid robot going and like hugging people and high-fiving on the beach and things like that. I don't think any of these companies could have really done that. Like it's a couple students, right? So like I think that there are trade-offs, right? But yeah, I don't know. I think it's pretty cool. I don't know if I answered the
Um,
question at all.
No, yeah, I mean the everyone knows about the resources and the quality of people that you're working together with. And I mean, just yesterday, I think it was Sanctuary AI just posted a new video about Phoenix and what it can do. And so, especially if you hang on social media, as you said, right, in the last year or in the last few years. Not only papers, but the work from students on different levels into their research is shared much more publicly, and people can really participate. So and then because normally who reads paper, right? Only people that are really deep into research. And but now that you can see and students share within their groups on social media, and then you see, oh, okay, so people are working on these kind of things. So I think it's not that far away anymore versus you are so the zeitgeist, you're much closer to the pulse of the technology, so to speak, so that you can really in real time see what people are working on. And normally, only if you're within the bubble that you have actually access to what people are working on. I think this is definitely some democratization that is happening through social media.
Yeah, I'm a really big fan of this. I think that the fact that there is, um, I think it is much more possible than ever before for like students or researchers at like less well-known institutions to be able to do something cool and put it out there and have people see it. And I feel like it's really important. I feel like it kind of there's a degree of like gatekeeping or like I guess maybe privilege that you get being at a like really prestigious institution, which I think it would be good if that was broken. I think personally, because I feel like it's better if everyone can share ideas, and I think it makes us all better off in the long run. So I think that's exciting. I think that the corollary to this and one of the problems with robotics specifically, like so you see cool ideas coming out of like machine learning labs because all you need is GPU compute, which is pretty fungible, right? Like I can pay Google for or NVIDIA or someone for or Amazon or Microsoft for cloud credits, right? Um, Robotics, you need hardware, right? And I think that is so. One thing that goes hand in hand with this is that there are a lot of really good quality, cheaper robots coming out now. Like there's the X-Arm, I think you can buy, which is like a $10,000 collaborative robot, which Google has used for some of their projects, I believe. And so like there's the chain continues here, right? So that kind of lowering the barrier to or there's the humanoid I mentioned earlier, which is just off the shelf hardware, right? And if you get those, that I think is also really good for getting people into robotics. I think it means that like one of the biggest last big barriers to entry is hardware. It's getting something that you can use well that doesn't like, and by hardware I don't just mean like the actual machines themselves, because you can of course buy like motors and whatever, but like making sure that it works reliably, that you can actually like collect data on it and run experiments. Ideally, if things are actually cheap enough, everyone will be able to share their data and at some point in the future and share models. Like I think this is something that, well, I can go off on this, but yeah, it's
I mean, we were speaking about breaking down barriers and making it more accessible to everyone, and especially in the US. I mean, you can see this. I have not experienced this myself, but I can see this on social media, on the news, that yeah, tuition became very expensive in the last few years. And then the question always comes up: is it worth anymore? Because there's so much knowledge out there, and you can teach yourself to become almost anything, right? Throughout videos and papers and courses and communities. But as you said, I mean, if we're not speaking about software, if we're speaking about hardware, then you do need to buy the stuff on your own, right? There's a lot
yeah,
of printing going on. So and as you said, a lot of electronic parts you can buy off the shelf and put them together yourself. But yeah, I mean, in the very end, if you really would like to build robots, it does become more expensive. And
yeah.
um, What I want to say is breaking down the barrier at university. I remember that I read on your CV that on your LinkedIn page that you did a internship in TUM. So this is a technical university of
Yeah,
Munich.
that's true.
So
Yeah.
this is over 10 years ago. So in Germany until today at least, go to university is still pretty cheap. So
Yeah.
if you go to university, you pay. I mean, it depends where you go, but the entire degree is 5 or 8K in total, right? So this
Yeah.
includes most likely transportation and all the administration. Books are for free. So
Yeah.
and so 5 to 8K versus. I mean, the figures can be, I think there's no end to it, right? But it can be anything between 30, 50K, 100, 150K, 250K for a degree. And here, I think this is definitely some uh, yeah, a barrier that especially as you said, if you're going to the prestige colleges, that holds back a lot of people because you need to be and even if you're very very good, only a very small percentage goes to those schools, and you do need to be in those schools, so it gives you a invest of return paying those kind of schools, so afterwards you have a job being able to repay that money.
I mean, I did not go to one of those top schools. I went to the University of Maryland, which is a good school for sure, but it's not like it's no Stanford, right? Like, I would say that like in the U.S., I don't. I think that a lot of the issue, a lot of the price of so college is extremely expensive. A lot of the price of it is also things like housing, like that's really expensive in the U.S. I think even compared to Germany. But not getting into that, like I will say like a lot of for robotics, it's useful to go to grad school, and in the US, you can usually don't need to pay for grad school. Like you might need to pay for a master's program at Stanford or something, but
Mm.
again, you can go to a PhD anywhere in the US. You will not have to pay for it. You'll get paid a stipend of like not very much money, like I think, but enough to get by on. So that does make it easier. You could always go to undergrad in Germany and go to a PhD program at TUM or at TU Munich or at like grad school in the US or wherever you want, right? There's plenty of good options. I mean, there's a lot of really great European universities, of course, too, for that. So at the very least, like that particular route, I do think like you have to be willing to do this, but I definitely agree that like this is obviously a big problem that goes much beyond robotics. I would say the
Yeah,
high
true.
cost of education. Yeah,
Yeah. Yeah, I didn't want to open up the box of
no,
Pandora
that's
when it comes
fine.
to politics or funding of these kind of things. I mean, you said that you are in research. Is there anything at the moment that you're able to share with us? Because I follow you pretty closely on social media, especially X. And yeah, you share plenty of things, right? So there's the Hello Robot. Would you be able to elaborate on that and tell us a little bit what is it about and yeah, what are you working on?
Yeah, so the most recent thing that we worked on was this OK Robot project, which is this home robotics project. So the idea being that like I want to be able to give the language command, like pick up the bottle and put it in the sink, right? And it'll go, and the robot should go and find the bottle, pick it up, and place it. And I think so. When I'm talking about, just to go back to the whole lowering barriers to entry, right? I think one important quality is that we can run this on off-the-shelf hardware, because I mean, as you were saying, like you can buy motors and build stuff, but I think that's a huge barrier to entry on its own. So you should be able to use it on affordable off-the-shelf hardware, which is what we used with the Hello Robot. Affordable being, I mean, it's 25K, which is a lot for a person, but not very much for a research lab. So
Hmm.
like, I mean, hopefully that'll change in the future. I think that there's a lot of individuals using Locobot and stuff, but like anyway, let's not get into that. So the point is, there are so we can so the way that I think about this is this open vocabulary mobile manipulation problem, which we proposed a while back, and I think that the core quality here is that this is like a basic primitive that is crucial to work on any robot in any home, to be able to build these kinds of applications. And so like it tests a lot of stuff like manipulation capability. It tests visual and semantic understanding, like what is this object that I named, even if I've not seen that object before, which is very important. And then you can use these things to place and then like same thing with locations, like understanding the sync, understanding where I want to search for this object, whatever, right? Yeah.
And these, how do I need to imagine this? You said so this is a team that is working on that project. Is like 5, 10 people, and then you think, okay, this is something I would like to achieve with this robot. So these are the things that we have, and yeah, please, if you're able to walk us through. So how is this? How is the yeah? How is the working process?
So we actually started on this kind of thing with a couple of projects last year, and so this culminated in this open home robot open vocabulary challenge. So this was a so what we did with that was this is like a 15 or 20 person team on that.
Hmm.
But part of that is like building a open source robotic stack, with like motion planner, RL skills, reinforcement learning based skills, simulation with a few thousand novel objects. And so what we did was that we ran this. So like this was part of this was proposing this task, put this task out there, which is this open vocabulary pick and place task that I think is like I said, is this kind of fundamental building block to get to work well on robots. So for scene understanding, so in that challenge, the robot has to move around and explore. And then build up this map of the house and be able to pick and place an object that it has never seen before. We ran a challenge at NeurIPS for this, which
Hmm.
is so we had, I think, 50 teams sign up, of which we chose the best 3 teams that submitted and tested their system in the real world, and then we were able to get a version of this running, right? A version, but one thing was that we never really got to try this out in a really wide variety of different homes. So this OK Robot project. I was collaborating with some people at NYU, Professor Lero Pinto, Mahi Shafiola, and we were able to, and then they're like, they have this project where this is a much smaller project where you scan a home, have the robot they use some pieces from the challenge from our home robot stack to control the robot, but you can move it around and you can pick it up and pick up objects, execute this task. Tried it out in 10 different homes. I tried it out in my home, and
Mm.
in addition, which was a lot of fun. One thing that I feel like happens a lot in these kinds of studies is that you can like people move objects around or make things easier for the robot, which of course, if it's my home, I refuse to do because I don't want to like move my dining table or anything like this to make it so the robot can fit through the gap. That seems like cheating. So like I really do feel like it, I mean, it works, like, which I think is pretty exciting to see. Works reasonably well. Like, there's obviously tons of things to improve, I think, that we talked about and that were talked about in the paper. Yeah, for the challenge, on the challenge side, so we were able to, like, I thought it was pretty fun to try to get like a whole community behind this project. The winner is actually in Germany. It was TU Bielefeld, I believe. So
Mm.
yeah.
I mean, these kind of challenges, especially if there's a community behind that. And I think a few weeks ago, I saw that Audrey Nash, who has a podcast also, was asking the question, why is the robotics community not as vocal and not as well connected and yeah, sharing resources like the web developers. So I mean, yeah. So I think his take was on why is this kind of community, the robotics community, not as active as the web developing community. And we both talked about the difference between software and hardware, and
Yeah.
so it could be. I mean that this is it's easier for people to outside of research to actually apply it to something and use it for something. So I think this could be definitely some of the topics that I can think of why web development can be. I mean, yeah, I think there was some discussion going on if this really the case, and then there's the community about open robotics, right? And there's a huge community in robotics. What is your take on that?
Yeah, so I actually think it's a really interesting question, for one, and I think it's an important question to ask. But I think actually I don't think web dev is quite the right one to look at because, as you said, that there's like a real market outside of it. Like I would look back at early computer vision progress from the 2010s. So when we had like when deep learning was taking off, for example, right? So there are lots of benchmarks and stuff like this. People always talk about benchmarks and how we can benchmark robotics versus machine learning, like vision stuff. And so that meant there was a lot of fast progress, a lot of development on things like models, like model architectures like ResNet or whatever, right? That appear through this period, and then as we eventually build up to transformers and modern models, right? So okay, so what's different about robotics? In my opinion, one big thing is that robotics is much less standard. In computer vision, like you take an image, you can write an image, take an image and you run detection on it, right? Like that's always the same. Like that's a very fundamental task. Anyone can run it. Now, my pick and place task is noticeably different from someone using, say, Aloha or Franca-ARM, right? Like, and there's a lot of reasons for that. Some of them are because like the choices of things like inverse kinematics and robot motion controllers all make a huge difference. In fact, probably more difference than your learning algorithm makes. And that's because just because like you tune this for how it's going to grasp objects, and like the impedance control matters a lot as to whether or not it'll succeed. And so all these little differences mean that robotics results basically never reproduce, right? And that means that I shouldn't say that, but like it's very hard for you to download and use my code on your robot in your environment, just because it's actually a different problem in ways that like the computer vision people do not have that come up. And so there are a few ways around this. One is simulations. Problem with simulation benchmarks. The problem with simulation benchmarks is they very rarely meaningfully matter in the real world. Now, I should say for our challenge, we actually saw the ordering of contestants translated perfectly from sim to real. I do think, meaning that like the first place was in sim was first place in real, second place in sim was second place in real. That being said, the numbers were different. The success rates are different. The problems are slightly different. And I think that while it's promising, that does not mean that like you could just download this and use this task reliably in the real world either. And I think that that's a huge thing to keep in mind when it comes to robotics results. So the fact is that now I do think that it's a great challenge, and obviously you should try it out. All this stuff, the simulation, whatever. But that aside, I think that simulation has huge limitations. So that means that leaves hardware and hardware standardization. And so this is one thing why I keep coming back to like commodity hardware and cheap hardware being maybe one of the best things that can actually finally allow this to happen. Because if we actually have commodity, widely available hardware that can be used for stuff, then I think we will see the same kind of fast iteration that happens in simulation, that happened in these other fields, starting to happen in real world for robotics. But it is necessary that we actually have the same problems, and we actually have something that can make progress on those problems. And that is currently, or that has historically not actually been the case, no matter what it might look like. That's my opinion on this.
And I mean, especially if you look into the real world, I mean, you're trying to find real world problems and then trying to adapt on that. What I think it would be interested in when you're talking to customers, right? Then there's you always need to find a customer willing to pay for the solution that you have. So having a solution and then trying to find a customer is actually the wrong way doing it, versus you find a lot of customers that face the same problem, and then you build a solution for that specific problem, right? And then you have this then you have the situation that you have actually the same application necessary, and then kind of you can still approach it differently, but you do need to solve the same exactly problem because you face it in at different customers' places. So I think because this is just an idea, because you have so many different research takes and maybe the difference here is that the variety can be so wide, right? If you're into research, you're working on a problem, and then you go deeper into finding a solution for that problem. So versus if you go outside of the lab and then you find someone who is willing to pay for it, then it can be work as a filter, because then you will see there will be only a very few problems worth solving. And I think this can be one of the topics. And another thing you just mentioned, off-the-shelf hardware. I remember that seeing Brad Addock, so he's the founder and CEO of Figure, that he said a lot of things that they need to build their humanoid. The machines and the supply chain is not ready for that. So you do need to build, because you cannot take them off the shelf. I mean, there's robot companies building robots, but here's some. So the not only the tools, but everything around it needs to be built by them as well, right?
I mean, I think that's especially true for building these humanoids
Yeah.
in Western countries, to be honest. Like, I think that like this is probably less true, and if you were starting it in like the Pearl River Delta, right? Like,
Yeah.
I don't know. Yeah, the Guinea tree seems to be doing okay, but like, I think that this is, but I think, which is not to say that that's not true. I think that that's all a very good point, that a lot of this stuff doesn't really exist, but it also comes back to the fragmentation of like what robotics actually needs to do, right? So like there are like an industrial robot has very different requirements from a humanoid, right? And so when we're saying like, can you iterate as quickly on robotics as you can vision or web design, it's obviously not true, because just the tool chain, there's so many, the systems as a whole are more complicated, and there's so many more parts in them, and so many more places where even a small difference, like what kind of motor I'm using, will make a big difference in terms of like whether or not the robot actually works for this application, right? Like, or the control method that I'm using, whatever, right? And a lot of that stuff is again abstracted out by the cool robotics research results that you see. Like, they are not worrying about all these lower levels that Brett is worrying about, right? So like that means that that makes it a lot simpler for them, but it also means that those results don't reproduce the way that a real product needs to, right? Um, yeah, that's again, on my opinion. But I would say, so you said something about like real world applications, and I think that well, I think that it's very important. I do think that there's something to push back on there as far as robotics research, right? Because I think we should have people who are looking further ahead towards markets that don't yet exist. Like, I think the humanoids, home robotic stuff, like humanoid layer factory stuff, whatever it is really exciting. But that market may not exist yet, and maybe one that you need to create, right? Like, there's that famous Henry Ford quote about like the um, yeah, about like when he was first building like commodity automobiles, about how, like, you know, if I'd asked consumers what they wanted, they would have wanted a better horse, right? Not every market exists. Like, we should be able to push past that, right? So that means that so like there's a room for both. There is room for both, I think, right? Yeah. And the other thing is, like, real applications definitely go down on this. Like, it should actually work. And there is a hardware, and there is a particular like viewpoint and like camera angle or whatever the assumptions are that I'm making. I can make those assumptions, right? That doesn't mean that it's it. Yeah. Does that make sense? Or that seems,
Yeah.
I don't know.
I mean, especially if you're, I mean, we were talking about challenges before, or coming together and having different teams working on these kind of things. There's actually the point where you go on into the real world, and then you have, it's the same when you're building up something for a demo, going to a fair or exhibition. It is, if you're going into the factory, for example, and then you have a robot um, executing a certain task. There's not too many people trying to play with it, right? So, but on an exhibition, they would like to test it to the extremes. So, what happened if, right? Especially when it comes to startups. So then you have a bunch of engineers or people from the shop floor and trying to test the robot to its extremes, right? So versus if you're in the lab, you're testing extremes as well, but it's still the lab environment versus the manufacturing environment, right? And I think
Yeah.
here sometimes I have the feeling that the working in silos, sometimes it's hard to think out of the box or out of the silo, because you are not displayed to the environment that could have happened. And I think here it's sometimes very hard to think about the things that you cannot think of. And so I think
Yeah.
going to one of those events or having these kind of challenges, mixturing people from different backgrounds and different experiences, and it can be an
Yeah.
exponential learning curve.
Yeah, I think that's right. Well, yeah. So I actually went to the Hannover Messe in Germany back in 2016 or so, like the big industrial
Mm.
robotics trade show.
Hmm.
I don't know. I'm sure you've been, but like for me, it was
Yeah.
like it's just wild how different that is from a lot of the robotic stuff that I'm used to seeing. And there's so many. I think I forget what year it was, but it was the year that Franca Emiko was launching their Panda arm, because so that you get to see
Mm,
their fancy new booth and everything. I was there with Kuka with their innovation
mm.
award competition, which was fun, just like very cool stuff. Like I think that I definitely agree with what you're saying about how like there's all these different perspectives you can get, especially with robotics. Like I feel like it is eye-opening how many applications there are for these things that are so different. One thing that I feel like I never see in research that I remember being super impressed by there are like these like picker style robots, the Delta robots.
Oh yeah.
Um, yeah, which is blazingly fast. Like seeing those things like play ping pong with someone is just it's so cool. I don't know, but the yeah, and I don't know. Yeah, you definitely don't see that on the research side. It's always yeah, very interesting. But
I mean, when it comes to community building or community in general, I think the open source. I'm always in talk with Trent Shumay and Rob Knight. So they're working on the Dex hand. I don't know if you've seen it. And so here, I mean, here's the goal. Here, the goal is to have a community as I mean, there's a big community behind open robotics, right, with Ross and Gazebo, and so people are using this already, and in all variety of different applications. But when it comes to robots, I mean, maybe humanoids are a bit different here, but having more people working on these kind of things and making it more accessible for them, I think we haven't had the breakthrough yet as we had seen it. I mean, last year was obviously the mainstream breakthrough for AI, starting with
yeah,
ChatGPT, but also the all the AI tools, text to image and text to video. And I think, do you think this will be happen soonish in the robotic industry?
I mean, I think personally, I think it's going to be gated by the hardware guys, not the software guys. Like, I think that
Hmm.
it's going to be whether or not we get like good commodity hardware that people get behind. And I think we're seeing the starts of that. So my guess is that yes, within like 5 years, things will have a breakthrough. I mean, I'm a little bit more cautious on these things than some people. I feel like because I
Mm.
don't know. Yeah, but I think so. Yeah, in the end,
I mean,
yeah, because
yeah, I think especially founders or yeah, startup founders or startups in general or investors are much more pushy on those topics, and
yeah.
because yeah, I mean you do need to have a vision and see how things are coming together. But as you are so deep in research, I think your opinion or your point of view is maybe a little bit more closer to the reality.
I mean, I also think I tend to be a little bit more conservative with a lot of these guesstimates because, like, I did like a lot of my formative robotics experiences were in self-driving cars, which I think are a little bit turned out to be much
Mm.
harder than everyone expected.
Hmm.
I'm sure something will happen, honestly. But I do generally agree with all these founders. I do think like robotics is going to take off, and it will happen soon. That we'll start to see a lot of these things happening. That's my guess, but. Um,
I mean, there's a lot of things that you can print already, right? When it comes to hardware, and even print pretty good. And at least in the last 5 years, I mean, these printer became very cheap and pretty good. And I do know a few people that have more than one printer at home. But I mean, the electronic parts and sensors and I think these parts. Even though they are
yeah.
accessible and there's plenty of things out there, I think this is something that is still there's still I mean, if you see founders or investors, everyone is really looking towards software because the margin is higher. It's easier to distribute and easier to work across different countries. And so here I'm really keen and really curious to see if there will be some startups in the near future that trying to tackle that topic.
Right. Yeah. I mean, I think that I do wonder if like vertical integration, like having like the platform and the software all is the right model for this, which seems to be what a lot of these guys are doing on the humanoid side. But from the open angle, like I do think one other thing that's exciting is that I mean I might be wrong about the hardware side, right? There's stuff like there's stuff like the OpenX embodiment from Google, where they build like these huge data sets with many different robot platforms. It may well be that the combination of robotics plus foundation models lets you circumvent at least some of these problems and get like at least baseline functional hardware on your kind of open source robot, which I think, or sorry, software on your open source robot that you were talking about, right? Like that would be pretty great. I think that basically that in a way is still agreeing on a custom platform because we can like collect the data and accumulate large amounts of it. Basically, the big issue with robotics is that has always been with when it comes to an AI, like a chat GPT moment, is that there are so many more ways for robots to interact with the world because like you've got this high dimensional like continuous output. Like you have to be reliable with it. You can't have your robot like blundering around and knocking things over, which means that which is fundamentally different from ChatGPT, which does not need to be reliable because it's something that you do in a dialogue. Like I correct it or restart the conversation if I don't get the result I want, right? So like it's reliability is not nearly as big of a deal for text-based models as it is for robots. It is very important for robots. That being said, to get to that kind of ChatGPT moment for robots, we need data. So we can either collect that on hardware, right, which you can do if you're figure and have like a fleet of humanoids, or you could do something like you could or Google with their fleet of their little robots right. You can also we can also like collaboratively share data from many different platforms, which I think is the OpenX embodiment sort of direction, right? And so yeah, I don't know. I think there's so many different promising directions, and people seem to be trying a lot of basically all of them. So I feel like something will work.
What do you think about synthetic data? So yeah.
I mean, I think I've worked with some synthetic data a lot in my life. I think it's very useful and very important. I think that fundamentally, it's good at different things from web data. So web data is good for like capturing semantics. So things like, what is this object, right? What could I use it for? That's good. Web data is good for that. Synthetic data generally requires more engineering. Like you've got to have software people like build the simulation, make sure it's reliable, generate rooms, and so on. So it's very good for, I think it's good for kinematics and for like getting like a lot more reliable network models. So things like this is where like NVIDIA has done stuff like grasp estimators and pose estimators, and we did things like object rearrangement when I was there, and that stuff all works very well with synthetic data, but that's not really touching on the semantic side as much, or at least not to the depth that web scale can touch. So I think it was a former colleague of mine, you could do, was now UT Austin and NVIDIA had shared a graphic with like a pyramid, and the bottom level is web design, and the middle level is, web data, the middle level is synthetic data, and the top is like real world on hardware data. And I feel like that actually captures things pretty well, where like you basically like each one lets you build up and get solved a slightly different problem, part of the problem, but you do need all of them that are at very different scales.
I mean, I can't remember when it was exactly, but I remember it was a few weeks or maybe a few months ago, not too long ago, that there was a big release about this kind of collected data, open source. And so I think, yeah, if this kind of projects will happen more often, I mean, we will see what will come out of it, and especially
Yeah.
if you combine this with so you have accessible data, and then you have hardware that is accessible as well, and then you have the hard parts, some electronic parts and sensors and these kind of things. I'm very curious to see when will be this breakthrough moment, because I mean, you said it's 25K having a robot at home, because this is what when it becomes really interesting, right? When it becomes so accessible that everyone can actually have one at home and then program, and then you see people that are really into that stuff, and then you see, okay, this will explode, because then you have so many people. I mean, I don't know what the price point should be. I mean, the like universal robots, I think I mean, you can buy smaller ones, but like a bigger one, the price point is around 20K, 25K. So smaller or medium-sized companies are buying these, right? And you were talking about, for example, some robots that you can buy for research. That I do know a few that cost 5 or 8K. But yeah, it would be interesting to see, because there's a difference between just working on some things and
Yeah.
having an actually robot that can do stuff for you, right? Because then it becomes, I mean, it's interesting to play a game, and it's also interesting having someone who is cleaning your yeah, your flat
Yeah.
and washing your dishes.
Right. I mean, my guess is that my guess on price is that like we would really get that kind of explosion if you got it down to a good quality mobile robot to 5K or so. Like basically
Mm.
expensive laptop or like smartphone or Apple VR headset kind of range. That's
Yeah.
really but that being said, I think that like there's of course a bunch of progress that you can make before then. And I think you can get arms for that price, right? Like you were saying. But I think that the problem with an arm is that that's just a toy. Like I can't really do anything useful with an arm. I need sensors, I need compute, I need like, I mean, you can do like at home, what am I going to do with a single robot arm other than play with it?
Nothing.
And that's a very expensive toy. But like I guess a robot with an arm, a mobile robot with an arm is also a very expensive toy, but maybe I can actually get it to like pick something up and put it down somewhere, which starts to
Mm.
like be the fundamental building block of something useful at least, which is why I care about this open vocabulary manipulation thing that I was talking about earlier. But anyway, right. So that's the thing, right?
Normally I'm asking people, so what do you aim for? Is there anything in particular that you think, okay, this would be something I would like to achieve, or so this is something that we're working on right now, and we would like to, I don't know, to realize this within a certain time frame. For example, I was mentioning the two guys before with the deck send, so they're now trying to find a market for that actually, and what is your, I mean, you're still not that long with Meta, right? And you've been with NVIDIA for 2 years, I guess.
Yeah. I mean, I think that from my point of view, 4 years, but from my point of view, I think that what I would like to see is, well, it's a lot of the stuff we talked about, right? I think that we should see platforms like widely useful software which can let robots go out into the real world. I think that part of this is going to be building a foundation model for robotics. What that means is very much up for debate because I think there's a lot of different versions that it could take, a lot of
Hmm.
different representations that could be. If we can do these things, if we can and it's part of the first one, right? It's really widely useful software for open world robotics. And I think that if we can do that, then we can start to make progress on so many different fields. Yeah, it's kind of a vague answer, I guess. But,
And then where do you see those open robotics, how do you say this, platforms?
um, the open, like the hardware, or
No, I mean, I was talking about like Ross and Gazebo
oh
and
yeah, yeah. I mean, I feel like Ross is. I'm a big Ross fan, actually. Like,
okay.
I think that it's important as in the end, robotic systems tend to be very complicated. I think there's a big tendency of people, I think a lot of people look at Ross and like, this is too complicated. I don't want to learn it, which is never a good idea because there's a reason it's so complicated. It's because robotics is super complicated. And I think that, so I tend to be a fan of it. Honestly, I have to admit somewhat shamefully that I have not tried Ross 2 yet. So I should do that. I want to do that at some point.
Mm.
Yeah. Is that what is your
I mean,
opinion?
you were talking about how complicated it is, right? And how complicated it is. So this
Yeah.
is a barrier as well, right? Not getting into something because you do know if you open this door and it will only go deeper and deeper and deeper, right? Because there's so many different parts within robotics that are complicated on their own. And just the other day, I was reading. I'm not 100% sure if it was the CEO from NVIDIA. Like talking openly about you should not tell your kids or your students to learn programming because in a few years it will become obsolete, right? There will be a point. Why speaking the robot language when we can somehow, I mean, it's not there yet, but I mean the goal is, right, having a language that both speak. And so why not making them speak our language? And so why learning programming when there will be a point in the future where you can actually just, I mean, you're working on this kind of topics at the moment, right? Where you can actually just talk to them and
I mean, I think that we should put those comments in a little bit more in the context of the fact that like people have been trying to push like everyone should just learn how to code, like it should be a class in high school or something like that, which is just like, and I think that pushing back against that is probably a good idea. It does not seem like everyone needs to learn how to program. But that being said, people still need to learn. There are still people in the world right now who know Fortran or assembly, stuff like this, right? Even though we have compilers, I think people will always need to learn. I think there will always be people who will need to know how to code. And that being said, and I think that Jensen would agree with that, I'm sure, right? And then there's the fact that like writing optimal CUDA code or something like this might well be something that you still need someone to go through at some point. And then there's the fact that like for robotics, for the specifically learning a new framework, building a new framework that's slightly better than the old one, it's still like, yeah, I think I wouldn't say that it's a bad idea to learn how to program or anything like that for that, right? It's just like it may become a much more niche skill set in my opinion, right? Because like, so for example, like if you have that language only interface, let's go with the robots, right? I don't have a robot here, so I'm not gesturing or anything. But if we have, but if I'm going to my robot, right, and if I give it the language instruction, pick up the bottle and put it in the sink, and it works, that's fine. If I pick it, if it fails, now I have to figure out why did it fail. Does it, if it knows how it failed, then maybe it's like, oh, I couldn't find the bottle. That's one thing. If it's like, well, I found the bottle and I tried to grab it, and then and all my sensor readouts look good, and I think I closed my gripper around it, and then that still failed. Then what do you do, right? And then that, like, I feel like there's still going to be obviously more skill needed to solve these kinds of problems, or I can't see anything right now, that kind of like the classic Ross issue of like maybe something is wrong with my network connection to the robot. Like there's, yeah, I don't know.
I mean, my art teacher used to say you can only see what you know, right? So if you open up a car and you're a mechanic, you see definitely more than someone who is not familiar with these kind of things, right? So the vocabulary that you are learning puts you in a much better position analyzing, as you said, problems, because you do know what could it be, right? Because you do know, you can see behind it. And I think you are definitely right. There will always be a space for that. And yeah, and I mean, in the very end, uh, adoption, right? Disruption comes from adoption, and as sometimes it just takes time, and especially when it comes to so many complicated parts that are involved in robotics, it takes even longer to adopt, because there's so many variables, and not everyone is, as you said, you are such a fan of Ross that you are not being into ROS 2 already, right? And I think it will just take time.
I mean, I do want to try it. It sounds like they've made a lot of the right changes. It's just, there's always something better to do. So,
True.
which is of course a huge problem with uptake, right? No one really wants to learn a new framework, right?
Yeah. I mean, I'm not into programming, right? So, I'm saying this from a further point of view, but I saw that Rust is catching up on a lot of things, and so people love it. But then I was speaking to someone who said, yeah, I mean, even though a lot of developer are loving it to use it, there's still a very long way to go to make this the language number one, and especially when it comes to architecture, right? So C++ is still there, and you were mentioning Fortran. I remember during my studies that we had one semester of programming, and yeah, it was I mean, this may be exclusive to very old German universities, but yeah, I mean, there's still, because it's historically grown, right? There's so many layers to it, and especially in robotics, a lot of things are working on. I mean, this is one of the main reasons the big robotic companies are struggling so much with their robots, right? Because you have machines that are running for a very long time. You were mentioning KUKA or Fanuc, and they're running for a very long time. So the architecture that these robots have been built off, they're very old, and it's not that easy to replace them, because you would like to start greenfield, but you actually start on a like brownfield, and so there's a lot of mess going on, and yeah.
Well, Rust at least got a really big boost recently, I think, from the White House saying that all future code should be memory safe. C and C shouldn't be used, right? So
Okay.
yeah, I don't know. So but I think that's right. Like these but that's actually there's just, which goes to say that there's a strength to having governing bodies like this. So like, for example, like the Open Source Robotics Foundation saying that they're not going to push ROS1 anymore, right? Like that helps move everyone on. Like it means that I will, like, I have people have commented about like our open vocabulary manipulation code, that they want it to support ROS2 now. Like that's it's partly because people are like, there is actually a push to update these standards, and like takes a while, but as long as we have, like, community organizations are important for this kind of thing, right? And I think they allow it to happen, and I think it will happen, right? Eventually. It just takes a while, and there's always going to be people who are slower, like maybe like me, but we'll see.
I mean, if you're very efficient and you spend a lot of time to become very good at it, then your motivation to learn something new is not as high, right? Because then you become
Yeah,
a novice again, and then nobody. I mean, because we're having an AI vision system, right? The company I'm working for, and then you see a lot of people that have experience with vision system. They do actually, it's much harder for them versus people that don't have that kind of experience, because you're always trying to adapt the knowledge that you have to new systems. But if there's a new system that works differently, then you feel kind of stupid, and engineers not necessarily do like to feel stupid. And
yeah.
so, yeah.
At some point you just gotta bite the bullet, though. I feel like, I don't know, I feel like I've learned so many new frameworks, especially when it comes to like deep learning, which, like, I don't know, I feel like I started out with like the old school version of, like, not PyTorch, but before then there was I forget what it was called, but then going switching to TensorFlow, and then there's gosh, you're not gonna, I don't know if you would know this, but there was the one really popular framework for computer vision before TensorFlow, which was just like, I remember just editing like these huge documents, and I genuinely can't remember the name, but like TensorFlow, Keras, PyTorch, like these things have changed. Like it feels like every couple of years what you want to use
Mm,
changes.
mm.
Although lately it's been stabilizing around PyTorch for sure, but now there's, of course, Google has this very fast new tools, right? So there's always something new to learn, and like it's just like, I feel like, I don't know, I feel like you waste a ton of time to the if you change too early and always are switching which frameworks you're using, but also you eventually waste a lot of time if you refuse to change and just use the worst old thing, right? So I don't know.
I mean, in the very end, there is always the pressure from outside, right? If the adoption rate is fast and everyone is using it, I mean, then you're being in a different
Yeah,
position versus, yeah, nobody's using it, and everyone is trying to hold on to their old systems,
yeah,
and especially when you're, I mean, the provider of those things, right? So, the robot, like the companies that are actually using it, they are. There can be a facilitator, there can be an accelerator, or there can be a barrier, right? So if there's no one is adopting it, and especially startups, we all know 9 of 10 startups still like that is very very fast. So as you said, hopping from one thing to the other things might not be the best option.
yeah.
Hmm. I do know
I think it
that.
is eventually, but like, yeah, there's this different threshold for everybody. This is, you got to keep. I feel like this is another thing that I feel like social media is good for. Is like, I like these discussions that people have about this, because like it is a constant discussion, and at some point it passes a threshold where you need to switch, and you should not get left behind, and you should
Hmm.
always, like, you should always be ready, willing to, right? I think you should always be willing to try the new thing, but you may not, but it may not be it's often counterproductive to, I don't know. But there will always be someone for whom it is productive to switch earlier because they're having too much trouble with the current thing, and like you can read what they write and then make your own decision later, right? I don't know. It's a
Yeah. I mean, I'm not 100% sure regarding social media, because I mean, it depends what kind of bubble you are, right? And
I guess
some
that's fair.
bubbles
Yeah.
have totally different point of views. And yeah, you can get into arguments very easily on the internet. And I think here, as someone who are like you into research, I mean, you guys exchanging not only through social media, but on exhibition and fairs and these kind of things, and workshops. And I think you get a much more better consensus versus the internet, and because there you have too many internet warrior fighting too much for yeah, their own goals. Yeah. I mean, for me, it was interesting to get a because we talked earlier. I think it was last year. I just had a baby, and now you're just on. I think you're still on paternity leave, right? So it was nice to get a deeper look into what Chris Paxton is actually doing. I follow you on social media, and I'm always keen to see what you're finding because, as I said, there's different bubbles, and I do like to have my bubbles filled with people that are sharing interesting stuff, and I'm always enjoying the stuff that you're sharing, and not only about robotics and sometimes opinions as well. So I'm a fan of your opinion and your humor. So please stay with us, and thanks for giving me some insights in your journey and the things that you're working on.
It's always fun to talk. So, yeah.
Yeah, so I'm saying thank you, and I think your day is still I think you're 6 hours or something behind, so your day is
It's
still
noon now, so time to go get lunch, I think. So
yeah.
it's
For me, it's time to go, time to have dinner. Thanks for taking the
okay.
time, Chris, and yeah, looking forward to talk to you again in the future.
Thanks. Bye.
Bye bye. Take
Great
care.
seeing you. You too.